All right. The second way that we're going to write these sequences is in recursive form. So let's imagine we have a sequence and it's 10, 12, 14, and so on, right? The first thing I notice about this is it's arithmetic, right? Because we're going by a constant growth factor of like +2. So recursive form is pretty straightforward. It takes the idea that all you need to know to form a function was where to begin and how to get to the next term, right? So I just made this one up on the spot. I just said, let's start at 10, and then what do I want to do each time? And I just thought to myself, okay, do something easy because you don't want to make a fool of yourself. Just add 2. I can add 2. So you go, +2 is 12. Well, how do I find the next term? I'm just going to add 2 to it, 14. How do I find the next term? I'm just going to add 2 to it, 16. And that's pretty much all you need to do to make a sequence. So what recursive form says is, let's just take that idea and kind of formalize it, right? So with recursive form, you know how in explicit form we start at a sub 0? Well, with recursive form, we're going to start with a sub 1. Now, this is just a way of denoting these numbers, right? So there's no wrong or right way to do it. We're just going to go with whatever makes our life easier, right? And for us right now, this is going to make our life easier. So, like I said, what I needed to know first was where to begin. So this is the formula in recursive form. Everything that I'm going to put in this box, there's 2 parts to it. There's the beginning part and like the how we move part, right? So I need to figure out where I begin. So the first part is just the initial case. Hey, we start at 10. How do I get to the next one? So if I want to find any term, all I have to do is take the term before it. Well, if this is any term, the way you say the term before it is like this, right? A sub n minus 1. That means if this is term 3, this is 1 less, which is term 2. So if I want to find term 10, a sub 10, sorry, I want to take a sub 9 and do something with it, right? Because it'll just be 1 less. Now, this time, each time I just add 2, right? So that's the thing I want to do. I want to just do +2. And so this is how we write the function. So there's it's kind of weird. It's the first time we've had an equation where there's 2 parts to it. Let's try a different one, huh? This one, let's do a geometric one. Geometric means that it's going to be growing with multiplication. So I'm going to do, let's start with 1, 5, and so then that'll be 25, etc. So once again, start off, probably a good idea to just remind myself that this is how I'm counting. I need 2 things. I need to figure out how to begin and how to move to the next term, right? And this is my function that's going to do it. I begin at 1. How do I get to the next term? Well, I'm just going to take the term before it, and each time I'm multiplying by 5. So you could write it like that. An alternate way to write that is you could say 5 times a sub n minus 1. Just because multiplication is, it doesn't matter which order you do it in. So sometimes you'll be asked to create the equation. Sometimes you'll be given the equation and said what sequence does that make, right? So if I came up with this sequence, right? Let's say I started at 5, and it was a sub n equal. Okay. So what sequence is this? Right. Well, I can go, I want to find some terms of this sequence, right? And so on. I know from this equation, I'm going to start off at 5, and now I need to figure out how to get to the next one. Well, all I got to do is take the one before it and subtract 3. So here's the one before it, 5 minus 3, 2. How do I get to the next one? I take the one before it, subtract 3. So 2 minus 3, negative 1, negative 4. And you kind of get the drift from there, right? Recursive form is a great form. We can write all sorts of equations that we wouldn't be able to before with it. The only issue is if I had to find a sub like 100, right? I would have no way, I can't just plug 100 into this, right? I would have to go through the entire thing. Recursive form is also really good for, this is a pretty famous sequence that you can write recursively, but you'd have trouble writing other ways. So you start off with two initial cases for this one, and to get to the next one, you do like this. So this sequence right here, it tells me my first two terms. My first one is 1. My second one is 1. Okay, so now the question is, how do I get to my next one? Well, I know that this means the term before it, 1. And if I go 2 back, I'm looking at this one. So what this is telling me is I add the previous two terms together to get the next one. So 1 plus 1, my next term is going to be 2. So how do I get this term now? I take the 2 before it, which in my case is 1 and 2, and add them together, and I get 3. How do I get the next term? Get these two together, add them up. 5, and then 8, and then so on and so forth. That's the Fibonacci sequence. It models a lot of crazy stuff, and it's best defined recursively, referring to itself.